So this is a pretty sad moment for us, at least it is for me. I mean, this is the final lesson of the term. Take a moment. Okay, that's out of the way. Let's go to the last lesson. Model selection. So with the last lesson, I talked about multiple regression, and I threw in a bunch of variables. It's multiple regression is where you throw in a bunch of variables to try to predict some response variable. Now, the best model is not always the most complicated. It's not always best to just throw in a bunch of variables. For one thing, the more variables you use, the lower your degrees of freedom are going to be. So there's sort of a trade-off between more variables and degrees of freedom. So sometimes, if a variable is not useful, it's better off to just have the degrees of freedom. So sometimes including variables that are not evidently important can actually reduce the accuracy of the predictions. However, it is not always clear when a variable should or should not be included, and as in the final model. So a strategy needs to be developed that will help us eliminate from the model variables that are less important. Alright, so let's start off. The model that includes all the available explanatory variables is called the full model. The full model is where you just throw everything in. So it's the kitchen sink one. It's the kitchen sink model. Our goal is to assess whether the full model is the best, and if it isn't, we would want to identify a smaller model that is preferable. So go back to the last lesson. Here is Mario Kart data. This is where all the variables, we had 4 different explanatory variables. So here's the full model. This is where all the variables were thrown in. Now, the last column of the table lists the p-values that can be used to assess hypotheses for the following form, that each of these p-values is basically whether that row, the parameter for that row is equal to 0 or not equal to 0. So you can see like this one right here is for the intercept. That's telling me, well, essentially it's a very small p-value, so it's telling me that the intercept is not 0. The next one, this one here, is for condition new. That p-value is very tiny, so basically condition new is important to the model. So the slope for that is not 0. So what that basically means is that having a game new adds to the price. That's what the model's saying. The next one, the p-value 0.3085, not important. So what we have here is my point estimate was $1.08, so I added $1.08 to price, but my standard error was $1.06. So really, whether the $1.08 actually added the price, that really could have just been random chance. And my p-value here is basically saying that stock photo really doesn't add anything meaningful. There's no significant meaning to it. Or it doesn't add anything to the model. Next one, even worse. P-value almost 90%. So it's saying that duration really did not add anything to the model. So I mean, my point estimate was about basically a loss of 3 cents for every day. But my standard error was 0.19, which should be larger. So this is effectively 0. The last one, the p-value, 0.0000, so wheels is also important. Alright. So again, the coefficient of con nu has a test statistic of 4.88 and a p-value that's about 0. How can this be interpreted? I guess, again, what I mentioned is that basically I'm saying that the having a game new adds to the price, essentially is what I'm saying. So this is essentially having a game in new condition is important to the model. It does add to the price. Alright, identify the p-values for each of the variables in the model. Okay, so all that column there. Is there strong evidence supporting the connection of these variables with the total price of the model? well, again, con new is important to the model. Wheels is important. Looks like stock photo and duration are not. Based on the p-values. Con new and wheels have very tiny p-values. Stock photo and duration have relatively large p-values. So there is not statistically significant evidence that either stock photo or duration variables contribute meaningfully to the model. So next we consider common strategies for pruning out such variables. It's not a good idea to just eliminate them, because what sometimes happens is getting rid of one variable sometimes makes the other one important. So we might not want to get rid of both variables. There are two common strategies for adding or removing variables in a multiple regression model. One is called backward elimination, the other is called forward selection. And they kind of work in opposite directions. But these techniques are often referred to as stepwise models because they add or delete one variable at a time as they step through the candidate predictors. So let's start with backward elimination. The backward elimination strategy starts with a model that includes all the potential variables. So we start with the full model. Variables are then eliminated one at a time from the model until only variables that are statistically significant. The important thing is you do it one at a time. So the strategy within each elimination step is to drop the variable with the largest p-value, refit the model, and reassess the conclusion of all the variables. So, for example, there you go. Results corresponding to the full model are for the Mario Kart data shown here. So, how should we proceed under the backward elimination strategy? So, we have two variables that are not important. This one is not important. This was not important. There you go. The larger of the p-values is 0.8882. So, that would be not significant. That's more than 0.05. So the backward elimination strategy is we would delete duration. And then what we do is that we get rid of this, and then we would redo the model without that variable. Now, doing that will change all the other numbers. So let's see what happens. And there we go. Now if you notice that duration has been removed and a new model has been fitted. So now we just have three variables. Notice the degrees of freedom has gone up. Now how should we proceed? Well, again we have 0.2747. That's a bad p-value. That's more than 0.05. 0, that's the only one. So I guess this is the only one that's more than 0.05, so that would mean that we would want, now we can eliminate stock photo. The idea is just do it one at a time. So I'll eliminate that, get rid of that row, and I'll recompute now with just the two variables. Notice that between the previous example and this one, notice that the p-value for stock photo changed a little. In the full model, it was 0.3085. In the model that did not include the duration variable, it was 0.2747. So the p-value changed, and it could change a lot. So it is common for p-values of one variable to change due to collinearity. So after eliminating a different variable, it's common for the p-values to change. This fluctuation emphasizes the importance of refitting a model after each variable elimination step. What sometimes happens is that a variable might not be important, but when one other variable is eliminated, it suddenly does become important. So in my latest model, we see that the two remaining predictors have statistically significant coefficients. All my p-values are about 0, so now all the variables here are important. Since there are no variables remaining that could be eliminated, this is where we stop. This was what I would consider to be the best model. So let's write out our final model for predicting the total auction price. So my prediction for price would be 36.78. Again, what we do is we read off our estimates. And then we did 558 for the condition. And then I would add 723 for each wheel. Okay, so what is the expected price for a new Mario Kart game that includes 2 wheels? So, well, let's write this out. So the price I would expect would be $36.78 plus $5.58. New means that was, remember, it was coded 0 for used, 1 for new. So 558 times 1, and then for 2 wheels, it would be 723 times 2. So 36.78 plus 558 times 1 plus 723 times 2. So my prediction is that this game would expect to sell for $56.82. Fine. What is the expected price for a used Mario Kart game that did not include any wheels? So my prediction for price would be $36.78 plus $5.58. Well, used means that was coded as 0. And did not include any wheels, so it'll be 723 times 0. All right, I don't really need a calculator for this one. That's just going to be the intercept here. 36.78.